we will head over to our next presentation and welcome on board Nick.
Hello. Greetings, everybody from Philadelphia over
Yeah.
here in the United States.
Welcome, Nick.
That was a great first presentation, and I'll just try to keep the standard high over here.
Ooh, thank you very much.
So yeah, I'm talking today about Clojure, particularly as a choice to use for your startup. And so, many of us like functional languages. There's always maybe some sense of thrill about the idea of using one on the job. But from the other end, as a founder, isn't that sort of a reckless choice? So I'm talking essentially about how I don't think it's a reckless choice. I think it was a very sensible choice. Just a bit about me. So yes, at university, I was a physics major, had just a couple of programming classes from around here in Philadelphia, which city about 90-minute train ride from New York. It's where the Declaration of Independence and the US Constitution were written. Those are our main claims to fame. And yeah, after a year or so out of university, I found myself working in a research lab at the university within the medical school, just kind of learning programming on the job, and had the chance to also take some courses at the university. And yes, the second semester of the Java course, the professor took one day to introduce this language, Scala. So this was probably about 2011. Language, I think, was still relatively new to the scene, and he talked about it being just something really big, and I took to it from the beginning, was somewhat involved in the Scala community for a time, but when it came time to find a job, I just ended up getting a job at a Clojure shop. Worked there for a couple of years, took a few years more or less off, just kind of freelancing. And when I came back to work for Crossbeam just about 4 years ago, which was the first year of the company's existence, ended up also being a Clojure job. So I think after the second time, I'm officially a Clojure guy. And as the company grew, as the team grew, we found the need to add a management layer. And so about 2 years ago, I moved into management. We have the company is called Crossbeam. Each of our engineering teams is named after a type of beam. And our team, with a bit of a sense of humor, I like to think, decided that we would be the Pinto Beams. And that's why the character sitting on my shoulder over there, you might wonder what that is. It's actually a stuffed can of pinto beans. So that's the kind of thing you get to spend your day job doing once you're in management. I'm enjoying that. But still a hacker at heart, and really like this topic. But I want to frame it. So I was not by any means the founder. I was just an early addition to the engineering team here. So our founder and CTO, Buck, is really the star of this story. If you've seen the classic 1993 American film, The Sandlot, I think I'm going for a similar dynamic here, where, okay, it's really Buck's story, but the narrator, Smalls in the movie, corresponds to my role here. So again, I was there, I saw the story, had maybe some small part to play in it, but mostly here to tell Buck's story, and have had the chance to work closely with him and collaborate on the message that we're giving here. So just to give a little outline of the talk as it lies out. So I want to talk just in general about this question of choosing a language for your new startup. And there's a good deal of storytelling here, because we are telling Crossbeam's story through the lens of these principles here. Though we do think there's something sort of generally applicable here, but also in every case, definitely particularities, contingencies. And so the history has to be told. I mentioned along the way, going to introduce a unit of measure, which is actually just a fake imaginary unit of measure for the sake of having some numbers and a little bit of a model of this complexity that we'll talk through, and tell more of the story. And then, depending how much time, can go into the very practical question of, okay, well, let's imagine that you're going with this niche language. Isn't that going to hamstring you when you need to hire? Maybe it's well and good to get to 7 employees, but can you get to 17? Can you get to 70? And I'll talk about that dynamic as well, again, depending how much time that there is. So, okay, to frame all of this, when you're starting a company, you might just think, well, you should use what other people have used. These are the RedMonk language rankings that they come out with, and towards the top, you can see the familiar suspects, JavaScript, Python, Java at the top. Trailing there, you've got PHP and some variants of C. So yeah, then you've got just a long trail from there. Clojure is kind of back here. I don't really think of Fortran as a peer that I want to have. So, well, if everybody else is sort of making these other choices, then doesn't that give you a pretty good idea that those are the right choices to make? So to address this, there's a quote from Steve Yaggy, a known engineering thought leader. He actually wrote the foreword to one of the better Clojure books out there, the Joy of Clojure. And Steve asserts that the industry is really just driven by fashion to a degree that would embarrass designers from New York to Paris. So I think really, the thing is, when you're starting a company, you can't run an experiment. You can't say, let's just try this once in this language and try it again in that language, or you wouldn't divide your resources in half and, sort of do a non-deterministic approach. You really only get one shot, just as if we all do in our human lives. So in something that feels very high leverage, most people go with what seems like a safe choice, something that at least lots of other people have gone with and will seem to do okay. So nobody ever got fired for choosing IBM, for example. And I think that really explains a lot of what you see out there. But you do get some glimpses of this alternative world. I think the most famous is this essay from Paul Graham about beating the averages, which, he and his colleague using Lisp ran circles around their 20 to 30 competitors. And it was really the power of Lisp that he attributed to that. And then, just 1 year ago, about in this very meetup, we heard from Adam about their experience at CodeScene, first implementing something in one language and then implementing in Clojure and finding how much better, how much easier, how much faster it was, even though Clojure was unfamiliar. So I'm aspiring here, if nothing else, to just add another datum to the story, which is Buck here at Crossbeam. And you'll see how we ended up starting with Python, but then moving on to Clojure. So let me just give a little introduction to what Crossbeam does. And essentially, we are writing software for people who work in partnerships between SaaS companies. So let's imagine you sell French fries, I sell hamburgers. We're not really competitors because people who buy your French fries might want to buy my hamburgers. So we actually have a formal relationship, a partnership, where we help one another out in the sales process. And there just haven't been software tools written specifically for these people. And Bob's, our CEO's previous ventures had really run across this problem and thought it was sort of a glaring opening that really needed to be done here, because there's a lot of benefit to be done through collaboration. But if it's not done sort of properly, securely, in a controlled fashion, then you have this sort of prisoner's dilemma where the party sharing more is at actually a disadvantage. So we built something of a platform where we both channel our CRM data into the system, and then Crossbeam tells you when there's a match according to prearranged sharing relationships. That's in a nutshell. So again, you have Bob. This is back 2018 or so. He has successfully exited from 2 companies actually, but hadn't yet really gotten the big one yet. You can just do a web search for this title, My $2.6 billion Ecosystem Failed. And you can see exactly how the previous go around, they missed the boat. Essentially, he was saying by trying to be a platform when they should have been an ecosystem. Whereas here at Crossbeam, we have the point of view that ecosystem is everything, that the other companies that make your company more valuable matter a lot more, a much bigger effect than other things you might look at. And then you have, again, the CTO, who I mentioned, Buck, who had worked with Bob in previous ventures and was out on his own doing sort of some consulting. And he met Bob and agreed to essentially write this prototype for this Crossbeam idea that Bob had. So what did he write it in? Well, he didn't write it in Clojure. He chose Python. And so I think that does illustrate, again, that every choice here is contingent and based on particular circumstances, and it's not as if there's just sort of one right answer. In this situation, Buck didn't know at the time that he would become the co-founder and CTO, and so this might really just be an engagement to get the prototype off the ground and then to be handed off to somebody else. In fact, Bob knows a little bit of Python himself. Knew PHP as well, but let's not talk about that. And so Buck knew Python really well, knew it would be easy to find, somebody else to take it over in Python. Bob also knew Python. It's sort of the lingua franca here, and therefore he went with Python here. So, year one proceeds. They raise a seed round. Buck does decide to come on as the CTO. You can see on the left here, there was a summer of interns who did, a lot of things at the very, very early stages here. And then, year one, there's a first of hiring. You can see me over at the rightmost here. This is our first year holiday party. So I had the chance to join pretty early on. And this prototype became production, and it wasn't just used for demos. We actually had some customers from a very early stage, and this was news to me. I, was accustomed to working for startups that weren't actually following that success trajectory that all of us aspire to. And so in this year one, though, we were already starting to feel some of the limits of that choice of Python. So indigestion, and there's a little bit of wordplay here because the specific system that Buck was working on here, the specific process is ingestion and matching. Remember, I mentioned that each of the partners channeled their sales pipeline into Crossbeam, and then we ran matching on it. And Buck had this all written and working in Python. And he just found himself looking at something he'd written actually not very long ago. And it wasn't actually that complicated, the inherent behavior that he was trying to express in Python. It wasn't actually rocket science, so to speak. And yet he found it surprisingly difficult to figure out how it worked, even though, again, he was the author of the code and it hadn't been that long. It took him longer than expected to make this actual change. And this just gave him a real sense of pause whether Python was going to make it for the long haul. So you have to have this perspective. Again, you start small, but you're going to grow. And indeed, we're about 4 years in now. We have crossed about 100 employees. We're over 30 engineers now. And it was still really enough to have second thoughts here and think, should we be doing something else? And it really comes down to this question of complexity. When you're writing code, you are spelling something out in such simple terms that the computer does exactly what you say and it will be the right thing. So you've got to make sense of the complexity. And you've got to think in terms of how much each engineer can unravel, especially knowing that it's not simple to just add engineers to the problem. By analogy, you could think of an algorithm that takes a certain amount of processing power, and you might think, okay, well, my processor is maxed out, but we can go concurrent, we can go multi-core, we can go distributed, and we engineers know how complicated all of that is, how hard it is, and you have somewhat analogous, I think even more intractable challenges when you're trying to get more humans onto a problem in such a way that your marginal engineer actually makes the whole unit faster and more productive. So thinking about this concept of complexity as sort of the most important factor when considering building software systems Because we have to deliver a lot of complex behavior overall. You're trying to encode, this data sharing, which can happen at scale, very securely. And every time you're adding features, you're adding complexity. So how do you actually unravel, swallow, handle that complexity while keeping from getting tripped up by incidental things, such as the language that you're trying to encode this in? So I'm introducing a made-up unit of complexity. Let's call it the Goldblum, after the actor Jeff Goldblum and his famous character in the movie Jurassic Park, with this scene in the middle here talking about chaos, which is a related topic to complexity. So let's just imagine, for the sake of being able to put some numbers into this model, that there's a unit, the Goldblum. And yeah, humans make sense of complexity, but it takes us time. We can only handle so much in a given day. And there's really only a certain amount that any human mind can do. Of course, some of us can handle more than others. Buck handles more complexity than just your average engineer, I think. And that is also factored into the model. And just Goldblum's character would find out that sometimes the complexity handles you, hence the little screenshot of the Tyrannosaurus here. So this, again, is just a made-up unit of measure for the sake of having a model that we can use to explain here. Just a little thing I found online, little Clojure lazy sequence there popping in there. Okay, yeah, so I've got a spreadsheet. This is not live coding, but this is just a spreadsheet. Let's examine the little model here. In the left column, you've got the number of engineers on your team. So engineer number 1 here would correspond to Buck. And then again, as I said, I think humans have a variable capacity to handle complexity. So let's say that in a given day, engineers can handle a certain amount of Goldblums. So I'm taking for granted that sort of your first few hires you can maybe know more about, and I'm saying that somewhere between 10 and 12 Goldblums are the early engineering hires. But that as you keep growing the team, you of course do your best in your hiring process to find the best engineers, but you still can only know so much. So I just have it as a random, somewhat lower number from engineer 4 onward, between 6 and 10. And another feature of the model is I'm saying that expressing the same system behavior in Clojure versus Python will require you to make sense of less complexity, will use up fewer of your Goldblums. And so, yeah, let's say that in a given day's work, expressing the same behavior in Clojure will cost you about 2 Goldblums, whereas the same thing in Python, let's say it costs about 5 Goldblums. So in that case, each engineer's Clojure productivity would be just a simple difference of their Goldblum level and the cost for Clojure, likewise with Python. So this is sort of the first order effect here. And this would be enough to go on. I've actually presented similar idea before with nothing more nuanced than this. Essentially, if you have a tool that is making every single engineer more productive than just by itself, I think would be worth going with. But I also wanted to try and incorporate into the model some idea of the cost of coordination. And the point here is that as you add more people to the team, you have to spend more and more energy coordinating between them. And this is just extremely rough, not a refined idea of how coordination scales with the size of the team. I just have it costing half a Goldblum more as the engineers come. So that gives you a chance to, again, just do a simple difference for each baseline productivity and say what the net productivity is, factoring in the cost of expressing it in the language, as well as the cost of coordinating across the team. And you can see there are, every time I edit a cell in this spreadsheet, the random numbers will reshuffle. And so we could get a few looks at this, but with this particular one, it's not even a guarantee that you add an engineer and it helps the team be more productive. You've got people, a few hires here. This is actually, I think, a particularly unlucky run, but essentially your first 3 engineers would be more productive than you added 5 more engineers to the team if the language is Python. Whereas at least you're still getting, more productivity in a less complex language. And so you can just look at the productivity of the teams here. And once again, you've got this velocity that's obviously much higher in our simple model for a team that's using an expressive language like Clojure versus, just a much less productive team in Python. So sure, I don't know, I can just trigger a couple edits here to see if there are any really interesting features that come out of here. But I think essentially this is the story that I aspire to tell here. And the thing is, though, I stop at 8 here for a good reason, because the coordination cost, once you get beyond about 8, really just becomes intractable. 8 is roughly what I think of as the highest number of engineers that you can have on the team. And at that point, past that point, you need to just split off, divide into 2 teams. And as I mentioned, that is a transition that we've gone through here at Crossbeam that coincided with me getting out of the coding chair and into the management chair, which right away shows you have a productive contributor who no longer writes code because of coordination costs. But yeah, 8 is about as far as you'll get. So let's go back to our slides here and discuss the features or the conclusions from this model again. Again, if you're only looking at the value per engineer, then even in that case, Clojure would be, I think, a better choice to go with. But there are also just these very fundamental limits of teams that go with the coordination overhead, communication problems, and so on. Adding more people to a team doesn't necessarily make it better. Adding engineers to a project doesn't necessarily make it deliver faster. That's the essential insight of this classic mythical man-month. And so at a certain point, well, you just need to add teams, but adding teams is hard. You've got to figure out the natural limits of the system that can actually be divided such that one team no longer needs to think about the domain of the other team and vice versa. It's very hard to get that right, and you need to make technical investments to actually make it work out. So, okay, what do, obviously, those red month rankings still have those tried and true, so to speak, languages at the top. And that is what a lot of companies are doing. So, well, what exactly do they do? How do they handle this? And I think the biggest answer is they go with microservices. And, at a certain point, you do need to split into multiple services. But they basically end up needing to do this much earlier. And the team, again, let's just think, that team velocity on Clojure with 8 engineers was in the ballpark of 45 Goldblums in our model. It was only about 20 Goldblums in Python. So that Clojure team can actually handle more than twice as much complexity in their domain. So you would need to split into teams less often. You wouldn't need to go to microservices nearly so soon. But as mentioned, he's talked to different CTOs. He's heard different ratios of microservices to engineers. And yeah, he's heard, for example, 20 services for 30 engineers. And that is just a huge ratio because the complexity doesn't go away. You just push it from the code into operations, and suddenly deploying things, running things becomes a lot more complicated. So having each team be able to handle a lot more before they need to go. And I don't really have time to go into, but there are also features in Clojure that make it so that you can have any of the benefits of microservices without the operational overhead, because you can still use a mono repo for a much longer duration. So yes, we are at about 30 engineers, as I mentioned, and we still just have the one Clojure service that gets deployed. And our different teams have their own slices of that, because Clojure's component system essentially allows us to have those boundaries of ownership without having the different operational overhead of different services. So yes, I think essentially what companies do is they go with microservices, as the tweet comically illustrates. That also introduces problems. And so ultimately, I think most companies end up just paying a huge tax here because of the language not handling the complexity for the engineers. Okay, so what happened in Crossbeam's case, though, as I mentioned, we had this sense that Python might not be good for the long haul. But we couldn't just, close up shop for 3 months and rewrite all our code in Clojure. It had to be bootstrapped, and I think also with the right mindset here. So yes, by this point, we have expanded our team. There was a Series A, we made some more hires, we got more engineers, and Buck is working on a proof of concept Clojure service in his nights and weekends. And it was not intended to be a full replacement of all of our Python code. It was intended to be just this core matching subsystem, sort of the most complex piece of our systems to that point. And so get the most bang for the buck, just buck, no pun intended, by just going with the subsystem there. And again, you wouldn't, in this realistic setting, think of a grand rewrite where, yes, we'll just completely throw out our code and do that. But it actually ended up happening. So, okay, we went live with this Clojure service. It's called Muncher because of the ingestion matching initial thing that it handled. And we went live in production with that. We cut over matching to that. And we have our Python service and our Clojure service running in conjunction in production. So at this point, Buck has a chance to do that point of comparison that I mentioned is all too fleeting. Adam mentioned it in his talk a year ago, where they had written in one language and then they rewrote in Clojure, where they had a sense of how much better that was. In this case, you have equivalent system behavior that has now been rewritten in Clojure. And Buck finds himself looking at fairly complex code that was written a while ago, and yet it was much easier to figure out how it worked. So this is the anecdote that flushes out the feature of the model here, where the fact that this was in Clojure allowed it to be a lot more comprehensible. And yes, this rewrite essentially, gradually, by stages did become grand. We ended up about a year later removing the last lines of Python from production. And there were two reasons for that. The first reason goes back to that same thing we mentioned about the operational complexity and overhead of microservices. So we didn't want to rewrite the data layer code in the Clojure service. So Clojure calls Python via API. So to make any change for something that the Clojure service is doing, you have to go and write Python, redeploy it. And yeah, it was just a little bit of a headache, even at n equals 2 services. That just felt like a pain. So yeah, I was on one of the first new features that we built after the launch of the Clojure service. It was a data request feature to say, hey, partner, can you share this data with me? And we came to a little bit of a crossroads where we considered, should we implement this in Python? Should we implement this in Clojure? And we knew at this point that if we implemented this in Clojure, that it was going to be inevitable from that point to end up rewriting all the Python code. And well, that seemed a little bit intimidating, but at the same time, all of us on the team at that point had prior experience with Clojure, and we just had an idea of how fun it was going to be. The idea of writing on Clojure just was a lot more motivating. So in a sense, we went for it. And I think that's actually important. I don't want to overlook that as us getting irrational, because again, these systems are written by humans. And if we already knew by experience that Clojure was going to be more satisfying, that we were going to be more productive, it was going to be better quality of life, then I think it was fair for us to make that choice, even for the engineering team that we couldn't foresee, even though we had an idea that it would keep growing. So again, there was this idea, okay, well, this is too complex with 2 services. And then also there was the sense of, well, wouldn't this be fun? So every project that we did, we just did a little bit of Python migration at the outset. And then at a certain point, we had rewritten enough of that we were able to bring some people on specifically to help us with migrating to Alaska to Python. And yeah, so before year 3 had dawned, we were fully running on Clojure here. And that was how that happened. So that does raise the question of, well, okay, we knew Clojure on the team at the time, and that was certainly part of how we felt secure enough to go with it at that point. But can you actually hire an engineering team and do that for the long run? Again, in this sort of niche language. And yeah, I have some more slides that I'm going to go over somewhat more quickly here. But the short answer is that, again, we're just about to split off our 4th core application team and just about 30 engineers. And the short answer so far is yes, if anything, choosing Clojure has made it easier to hire good engineers for our company. So, and it has looked a little bit different in different phases. That Series A round, which were the first hires outside of the core first few of us, yeah, I brought in somebody I worked with at a prior Clojure shop. So it certainly helped to recruit him. But also had a former colleague who used Clojure, and he came aboard. We hired a senior engineer from another Philadelphia company who had only worked as Scala before, but for whom this other functional language was a compelling choice. And so, yeah, even though it wasn't through the network, was also through this functional language. And so, a year later, we had a Series B hiring round, and we're trying to double the team again. And our persona started getting a little more varied at this point. So we're still getting sort of Clojure veterans, people who know Clojure, people who are looking for Clojure jobs. We also got, for instance, somebody who had worked his whole career in Java, but was really interested to try out this Clojure job. And we also wanted to get out of just hiring sort of senior and higher engineers and begin to hire mid and associate level engineers. And fewer of them had used Clojure before, so we had to have our first experiences really teaching new engineers Clojure on the job and see how that goes. There was also a Series C after that, and we've just continued to hire more. And again, we have a mix. There are people who just happen to stumble upon Buck's blog posts about using Clojure, and who, even though he has a really good job at a publicly traded company as a staff engineer, just wants to get out of Java land and try something in Clojure. We had that persona found his way to us this year. We have other people who, again, have no background at all in Clojure. And we've had a chance to really focus on the onboarding and the learning process there, and to have really good success stories. I've got a couple on my team of people who have come in and shocked me within 6 months or so how fully they internalized the power of Clojure and so forth. So essentially, this worked out. And it's actually, Steve Yankee makes the point in a recent talk he gave advocating that people learn Lisp. It's actually not that hard to learn a language like Clojure. It's not, it's a little bit of a different paradigm if we're used to the same old imperative way of doing things, but it's not that hard. And it's also not that crucial part of a person's job in some sense, because an engineer has to do so much before you're writing any line of code that doesn't have to do with expressing it in the language. In fact, my old mentor, Kyle Burton, would say that writing lines of code is one of the least effective things an engineer can do. So yeah, you can teach it. It's not that huge of a part of the day job for an engineer. And I just popped up my headphone cable 1 second. Yeah, then it does become not just a recruiting, but also a retention advantage. People get used to using this expressive, powerful language, and they're not interested in going and doing something else. Don't want to go back to the land of curly braces. Sorry, that's meant to be, really C represented there. Nothing against Scala. I think many of these points would go for other functional languages as well. And yeah, we've just had to continue every year. It's its own story. We've had success outsourcing to Clojure devs because You don't, not every person who knows Clojure is a great engineer, but there's definitely some signal there that there's a correlation. People who gravitate to Clojure tend to be better engineers. So even though many companies struggle with outsourcing, they have some collaborators in Europe who have done really well for us. They've been part of our team over 2 years now. And again, Clojure was a big part of the success there. We've continued to grow teams. We've gotten a lot more serious about getting the separated ownership and domains so that each team only has to handle so much of that complexity. Yeah, and we just added so much complexity to our Clojure code base since it first dawned. And yeah, of course, one feature I would change about the model if I got more sophisticated is that the cost of each language wouldn't just be this constant integer, but that it actually is something that varies with the lines of code. The bigger the repository gets, I think there's sort of more complexity challenges. And it's not that you don't face that at all in Clojure, you face it in any language, but we've had to continue to do more work to sort of make all of that tractable. And yeah, that's essentially what we do here. I have a few quotes from the engineers on their teams. One says, learning Clojure was a huge advantage. Other people said, well, we were really looking for Clojure jobs first and foremost. And so therefore, we obviously had a huge advantage of recruiting those engineers relevant to companies that don't use Clojure. And there's also, I think, a really important aspect about the community around Clojure, which is that it tends to be a very positive community that is just really happy to be here. We went to the last Clojure Con 2019, and there Rich is with his entourage, and everybody's just talking about how great Clojure is. And of course, you could worry a little bit about groupthink, but I think it's a sort of small enough tribe that we're not really in danger of, losing our minds. And because the Clojure community is this diverse entity, it is a really positive thing to bring engineers into from outside the community. And again, in terms of hiring and running our team, it's just been a huge asset. So yes, again, Clojure makes each of our engineers more powerful, we believe, and it makes it possible for each of our teams to manage systems with a lot more complexity. Again, I think it's more like your team has a budget of 45 Goldblums before you need to split off a new team versus, say, 20 Goldblums. And if anything, it has only helped us with recruiting and retaining rather than being some kind of challenge. And yeah, we know other companies, Nubank is out there, they have hundreds of Clojure engineers. So we certainly know it can be done and that there's a growing pool of people who already know Clojure. And so having gotten to 100 employees, 30 engineers, we have pretty good confidence of being able to continue to go through the next milestones of growth. So that is my presentation. And because I pulled out the headphone cord, let me make sure that I still have audio.
You do. We thank you.
Yes, great.
Thank you very much, Nick. Thank you very much, Nick. Thanks.
You're welcome. And sorry about the audio trouble.
Yeah, no worries. It's if you work with software, it will happen. You know that you will fail in production sometimes.
Indeed.
It's just how it is. It's life. Thank you very much. We also have some people in the chats saying that they're also like the Clojure community is also part of choose why you should go to Clojure. Anyway,
wonderful.
Yeah, I just want to mention that as it's shout that out. Well, thank for your presentation. I think it's really interesting this you talk about the complexity things. Have you done more things around this? The what it called Goldblum's matrix or revenge? I mean, that would be really interesting to start, comparing different languages, because a lot of companies today they just choose something randomly, or we go with the popular stuff, Java or C# or without making a conscious choice for the long term. More like we do this now. In the end, we're 200 devs. We're working on this,
Yeah, so this whole Goldblum idea in a spreadsheet is just something that Buck and I came up with in the last week. And it is just sort of a rough idea. And I would like to explore it further. Buck had some idea for you might be able to study it further, perhaps even a natural experiment looking at repositories on GitHub in different languages and how many people are contributing and so forth. But I do think it's quite deep. When I first started presenting on this idea, the intended audience were Clojure enthusiasts who would just be craving for the chance to use it in production and would live vicariously through the story. As I've thought about the subject more, I've realized that there is something really potentially very deep here that not just the Clojure enthusiasts, but anybody starting something should think about. So
I totally agree. Me myself, I went from I did C, C++, Java, and then 2008-9 I learned Erlang, and I had kind of the same feeling going from this to Erlang, is that it's less complexity. It's
indeed.
much easier to make the right choices as a developer. And then I had this thinking myself then, why, you know, if you're a huge company or a small company, why don't you choose a language that's going to help your developers? Because in the end, you know, it's as you say with the matrix you show, like you end up with gazillions of developers. You want to maximize their productivity. Yeah. Another thing, have you elaborated around team sizes and optimal team sizes, as you mentioned also in your matrix?
That really just comes from my experience the last 2 years in management. Maybe there would be different ways of running a team, but for instance, my team these days has grown to about 9 or 10. And just as the manager, it is really hard to stay on top of everybody's work stream at even that size. And so I mentioned we're about to split into 2 teams. So that's just kind of our rule of thumb. I don't know, depending, exactly how you run your teams, maybe you could have more on a team, but it does seem like around 8 is a band where everybody can be familiar with one another, familiar with the systems, good amount of redundancy, but not getting to be too large and too unruly for a manager to keep track of.
Do you see any uptake in the local community where you live around Clojure once you get started? I mean, the rumor spreads, you recruit people, maybe you get grads in, they will learn, things slowly. Do you see that?
I think honestly that's the story that we're in right now, because that first Clojure shop that I worked for was around 2012, and that's when Bob was also doing his first company, which also had Clojure. So our city, Philadelphia, is a little bit of a Clojure hotspot, and we have seen, again, here we are. We have a lot of us. It's not even our first Clojure job here. So yeah, in short, I do think we have seen that story, and I'm interested in seeing it continue as well.
Nice. I don't have any more questions. Again, thank you very much for your interesting presentation. Thank you very much.
Thank you. It was a real pleasure.
Yeah, you're welcome.
I'll see you in Sweden next time.
Come to Sweden, and before we started the live show, Nick said that he knew fika. So if you ever come to Sweden, you have to have fika. It's kind of the tradition in Sweden. Or if you work with Swedes, you know that fika is a tradition. Yes.
Got to experience that.
The Swedish fika. Thank you again, Nick. And if you come to Sweden, please ping and we'll have a fika so you can have the experience.
I'll be sure to. Thanks so much and have a great day or evening.
Good evening. Thank you very much. With that, people, thank you very much for listening in today, and thanks for all your nice shout-outs and comments in the chat. Also, we'll be back again in a month. Now we scheduled 3 meetup events, one for October, one for November, one for December. We have one presenter for each of these meetups, but of course, we're looking for more presentations. So if you have a presentation, you want to present something, anything around functional programming from anywhere in the world, please reach out to me. You can find me either on the meetup page or on LinkedIn or in any social media. Just ping me and we'll put you on. And with that said, thank you very much for tonight and have a nice evening, everyone. Bye.